Back to our side angle side notes video. Here we're going to look at proofs. We're going to try to prove side or side angle side. We got to remember all of those congruence tricks that we learned in 4.1 to 4.3. You know, our vertical angles, our third angles theorem, our reflexive property, our alternate interior angles might come up later in the week. So on this problem, we're going to try to prove this one by side angle side. I've got two sides there. I've got two sides here. And I already have, if you notice in the picture, two pairs of angles marked in. But I don't have the pair I need. I need that third pair of angles, which is right here. So if I can get that third pair of angles, then I can say that I have side, angle side. So all I need is the third pair of angles. All I need is this third pair of angles, angle P and angle D. So what I can do is, if I already have two angle pairs, and all I need is angle P and angle D, well, I know that if I already have two angles, that's in the wrong spot. If I already have two angles, then I get that third pair of angles for free by the third angles theorem. So angle P must be congruent to angle D because I already had two pairs of angles that were congruent. So by the third angles theorem, I should be able to get angle P and angle D. So now that I've got these angles, I have congruence by side, angle, side. I have two sides, DE and DF, and the angle in the middle. So these are congruent triangles by side, angle, side. And that's a lot easier than what we used to have to do. We can cut out a lot of steps by using this side, angle, side, or side shortcut. On our second problem, we're given that V is the midpoint of RT. We're given that RS and TS are congruent. We're going to try to prove this congruence theorem by side. So what am I missing? If I want side, I need to show that RV and TV are congruent. And I need to show that this shared side in the middle is congruent to itself. So I'm going to try to prove this by side. So what I really want is I want to show that, let's start with VR and VT are congruent. So I want to show that VR and VT are congruent. But how do I know that? I only know that because we were given that V was the midpoint here. And if that's the midpoint, then I know by the definition of midpoint that VR and VT have to be equal. So I can cross that off the list. The last thing I need to show is that VS is congruent to VS. Or SV is congruent to SV. Either way. And if something is congruent to itself, we didn't switch the order of the letters, that is our reflexive property. So finally, I've got everything marked in. I've got three pairs of matching sides, which means that I can just say by side, I've got congruent triangles. All right, this next one's pretty short. I would encourage you to try this one. We're going to try to prove by side. I've got one pair, 2 pairs of sides already. The only pair that I still need for side, side, side is LN. So I'm going to ask you to try to prove this one on your own. All I need to show is that LN is congruent to LN. That's the only step I need on step 2. So I would encourage you to pause the video, try this one, and then unpause and check your work. And if all I need to prove is that LN or NL is congruent to LN or NL, if I look at the congruent statement up in the prove statement, LN and LN match up. If it's the same thing, that is our reflexive property. And then I have 3 pairs of matching sides. So if I have 3 pairs of matching sides that are congruent, then I know that that is my side, side, side shortcut. And our last proof here, we're going to try to prove this by side, side, side again. So I need to show I'm given that AB is congruent to CB. I need to find why the other two pairs of sides are congruent. So you need to show that AD is congruent to CD, and you need to show that DB is congruent to DB. And once we've got those, then I've got side, side, side congruence. So please try this one on your own. Pause the video, check it out, and then when you're done, unpause and check your work. All right, so we were given AB and CB. If I wanted to show that those top sides in yellow are congruent, I can use this fact right here, that D is the midpoint of AC. And if D is the midpoint of AC, then DA has to be congruent to DC by the definition of midpoint. And then my last pair that I need is BD and BD. And if it's congruent to itself, that is our reflexive property. And now you could have switched steps 2 and 3, that's fine. It really doesn't matter, as long as you've got those two somewhere. And then our last part, ABD, is congruent to triangle CBD by side, side, side.